putting metadata on the map, producing enhanced geospatial visualizations from open source tools to encourage metadata creation earlier in the data lifecycle. And presenting for us is Sam Spencer, lead developer and community manager of Aristotle Metadata Registry.
Thank you very much. Thank you very much. So it's Friday, and this is kind of like, I was doing my talk, I was getting my slides ready, and I realized that as I was doing it, the map came right at the end, and the name of my presentation is putting metadata on the map. So I thought, I'm going to start this, I'm going to wake everybody up, it's Friday, I'm going to start this with a magic trick. I know, right? So, here we have some data. This is a regular CSV. Straight up, normal CSV of data, column headings that are already cropped off and you can't quite understand it. It's difficult. Put over the top some metadata. Again, as a CSV. And here we've got a description of all of the columns of our metadata as a CSV. And the reveal, it's a map. It's a map. And not only is it a map, when I click any one of these items, I get a full data dictionary that describes what that instance on the map is. And it's not magic. It's metadata. And that's kind of the key part of this talk, is that metadata isn't magic. Metadata is science. It's a very reproducible process. So enter the boring part of the talk. How do you go about the reproducible process of helping government realize that metadata is important? Well, to talk about this, I'll talk about the project that we've been working on for the past year of revitalising data.gov.au. It's been a very exciting project looking at how we can help people understand the information that exists at a whole of government level to find the harmonisations between data. And when they brought me on, they said, what about the metadata? And I'm like, well, for us to do that, for us to start having that discussion, we have to ask the question, what is metadata? Because for a lot of people, it's not an easy to understand concept. Now, at IASSIST, I can ask anybody here and they'll give me a very, very intelligent answer about what metadata is. And we had to kind of step people through this and say, well, what do you mean when you say metadata? And what we could really do is we could really start breaking it down into what I think are the two fundamental parts of metadata. Here we have another data set, and on the left we have descriptive metadata. This is holistic metadata that tells you about the entire data set, rights management, provenance, who wrote it, the conditions under which it was written. All very, very, very important information. And then alongside that, we have structural metadata. So this is the structural metadata definition that's used by 11179 that says, when I'm talking about one individual column, one individual item, what do I mean? Because that's really important. When I look at a number, I need to know what that means. And I need to break it down to a very, very atomic level for me to understand it. Now, that wasn't always easy. We started looking at what was available within data.gov.au. And data.gov.au, like many data.gov portals around the world, is built on CCAN. Now, this is the interactive portion. Has anybody here heard of or used CCAN? A couple of hands, great. So we can kind of start looking at this and going, what metadata is available within CCAN? Here's an example data set. I look at this and I say, this is a very rich description of a set of data. It tells me who wrote it, why, and as I can keep clicking through, I can see tags, I can see fields, I can see the license. I know under what conditions I can use this data. Fantastic. Really, really valuable information. How do I understand what this data set is? Well, I can see the data set, and that tells me something about it. I can look at the whole thing and I can go, okay, business name status. Well, what does a business name status mean? That was my first question. I'm not a member of the Australian Securities and Information Commission. I don't know what that means. I'm sorry. I'm a computer programmer. So I said, where do we find the definitions of what this data is? And it was in a PDF that was generated from a Word document in Appendix A, Appendix 2, all the way down at the bottom of the page. But the key thing here is this is good. This is great. This is excellent work. I saw this and I was very, very happy, and I'll tell you why. I know what field has what definition, and I know what's allowed to be in there. I can look at this and say, this column will be 200 characters wide. That's great. This is exceptional work, and I've said this time and time again. This person has done everything they could to describe their data. The only challenge is that it's locked up in a PDF. It's locked up not quite even in a table. It was a pain. I'll tell you, it was a pain getting this out. Like copy, paste, hand manipulation, risk of loss of fidelity just because of that process. So I said, how can we start helping people get through this? How can we say, give me better metadata? Because this is good, I just want it a little bit better. I want it machine readable. How can I link it back to a column? That's ultimately what it is. Because if I can link a description back to a column, I can find linkages between data. And that's what makes data linkage possible. So, what are the barriers to government metadata access? Why don't we have this already? Like, we know it's, like, we know this is good, right? Like, having good descriptions of metadata is correct, right? Yes. Yes. That was the correct response. Yes. So, why don't we have it already? Like, this is what we say. When we go out into the community, we say, metadata helps you find and discover data. I know where my data is. I gave it to you. It helps you understand data. I already know, it's my data. I understand it as best as anybody can. Gives you consistency across data. Well, I only gave you one. Like, I have one data set, I've given it to you, it's consistent. Provenance tracking, no, I know where my data came from. I was the one who made it. I made it, I'm giving it to you. Now it's your job. An easier reuse of data, and this is another really easy one to kind of cut down and say, I'm not going to be reusing it. I've used my data, I've given you my data. Reuse isn't my problem. I'm not resourced for that. I don't have the funds to do this. And I'm not saying, these aren't straw man arguments that I'm giving you. These are legitimate discussions. If somebody isn't resourced with or has the organizational buy-in to provide metadata, what are you going to do? Okay, so how do we improve? What did it take for us to kind of bridge that gap? Well, the number one barrier I found was education. People don't understand that basic differential between structural and descriptive metadata. And being able to break those down was key. I showed this video. This video was produced by us at Aristotle Metadata Tech. And I showed this video, and within a week of a 5-minute video drawn on a whiteboard, people were starting to say to me, structural metadata, descriptive metadata. We have lots of descriptive metadata. That's important to us. Like, great, now I know where the gap is. Bridge that gap. Bridge that knowledge gap so that when people say what they have and haven't got, we know what they're talking about. But once you've bridged that gap, where do we go from here? Well, I use the world's most advanced technology available to data science today, CSVs. I tell you what, CSVs are great. No, the challenge for us was, again, it was a tools perspective thing, but also it was an organizational thing. If I'm looking at someone to help me build data, to build information, to build structured information, often we can only use the tools that are available within an agency to do that. And every business, every government agency, every academic librarian has Excel installed. Got to deal with that. Just use it. A CSV is pretty good. A CSV definition of information is pretty good if you help people along the way. So what we ultimately wanted is we wanted their information to be structured. And this is how I like to structure it. This is the Aristotle Metadata Registry, or a screenshot thereof. And it says a business name is comprised of these objects. It has this description. It will meet this information. And these are all atomic breakdowns of a piece of metadata that says exactly what this is. I don't have to mine through text. I say, give me the data elements, value domains, maximum length. I can type that strongly against what the data is, and I've got some assurity. But how do you get there from a PDF? Have someone enter it by hand, every field manually. What we immediately looked at was we looked at some existing Australian standards, and we looked at what metadata, what data dictionaries existed on data.gov.au, and we sat down and we said, what are the top 10 things I need to know about a piece of data that I can put in a table and say, fill out these columns, don't add any more, don't add any extra sheets, Don't even give me codes. Fill these out and I'll understand your data. Like, tell me what you're collecting, what it's about, the property of it, how it's recorded in a piece of, in an actual database. You will notice that we did leave off codes. There are no codes that we record. If you try and record hierarchical information in a CSV, it just falls over. Add an extra sheet, I want to add a third. No, just basic stuff. Tell me about this. And it looks like this. So, a name, a definition, the object, the property, the value domain, the data type. Data type's really important. So we looked at this and said, okay, great. I now have a really clear understanding of what we're doing. Really basic stuff. And people engaged with this. They were happy to do this. Like, this isn't hard. Like, how long would it take you to take any spreadsheet or any piece of data and fill out, like, these 10 things? 5 minutes, maybe? How long does it take? So we upload this, and this is where it starts to get really technical and interesting, is we uploaded this information and we could find the gaps. We found the gaps and said, okay, that's great, but I need definitions for these things. They weren't in the spreadsheet. Can I have a little bit more? Just a little bit more. And it was this kind of, these slight nudges that kind of got people to kind of start adding that extra information. Sometimes you can kind of gloss over the definition of an object class. You can say, I know what a person is. I know what a business is. I can do that later. But giving them the option to nudge this forward was really important. So what did we do then? Well, we now had linked information back to that data set and said, this data set has these definitions. This column name has this definition. It has this data type. And it occurs this many times. So when I started looking at an actual piece of information in the registry, I got this. It's pretty much the same as we saw earlier. But the big difference is here. I can see all of the data sets that it exists against. And from a government perspective, that's actually really powerful. An engaged user using data.gov.au can now look at an interesting data set and find things that record the same data. That's linkage. Like, we didn't say we're going to make a data linkage profile. We just said, tell me about your data. And as we started pulling more and more in, we said, just tell us a little bit more about your data. And then, lo and behold, like magic, we had the information necessary to perform data linkages across this vast data set. But that's not all. I said maps. I promised maps. So as a quick rundown, we've all heard of CCAN. I hope a lot of you have heard about Aristotle. The other thing I want to talk about is an in-house product that was built by the CSIRO and Data61, where I'm currently working, called Terrier. And if you take one thing away, this is a pretty good thing to take away, because this isn't that widely known outside of the geography space. Terrier is an in-browser piece of technology that builds maps so that you don't need a GIS server, you just need a CSV. If you have a CSV that has appropriately marked latitudes and longitudes, you get a map. You have GeoJSON files, so JSON-based geography tiles, you get a map. It's pretty neat. Look it up. So, this is what National Map is. National Map is an instance of Terrier that's run to share government data on a map. So this is all of the business names within the credit licensee data set. And we did this. We did this. We did that. It's not big. It's meant to be a joke. It's not big. What it is it's not a column name anymore. It's a piece of metadata that says, this is what you're clicking on. When you're clicking on this, this is what it means. And when you click on it, you get a link back to the definition. So that when you're looking at this on a data set, or when you're looking at this on a map, you can know exactly what it is. It also meant that as you clicked on any particular item, you saw practically the entire data dictionary there, in the browser, next to the map. In the map, embedded in the map, against every value. And that was really powerful because, again, at no stage along this journey have we said, let's build a map, or tell me about your metadata. We just said, tell me a little bit. This is a product now that somebody within a data archive or within a government agency can say, hey, do we want maps? Do we want to share maps with the world? Because I think that's pretty useful. I think we should be doing that. This is us effectively saying metadata has value beyond just search and discovery, beyond just understanding, really valuable things. This says metadata has value now, so that when we're producing this information, we can understand it. It's not for somebody else's benefit, it's for my benefit today. And that was the core message that we said is, giving your metadata out, making it available, helps people do this. And it really resonated. So this is our architecture diagram, I guess, that explains how the process worked. What we did with Interior was we built a custom catalog that would go off and call a web service from Aristotle and say, please give me all of the data sets that you have that have appropriate metadata attached. We then use that information to fetch a CSV from CCAN, return both the data and the metadata profile to the browser, and draw them out. It's actually relatively straightforward. Getting the content is hard. Bootstrapping to encourage people to give you metadata is hard. Technically, it was actually not as challenging as you might think. So we went a little bit further. And I said, as the metadata guy there, I said, we can do a bit more. And we started pushing harder and harder. And the challenge was this. Metadata is useful as a way to see inside private information. Descriptive metadata, structural metadata tells you what's in there without you having to see it, without you having to have a synthetic data set or having confidentialization. I could look inside a health government data set and say, you record my name, you record my identifier, you record my health conditions. I can't see any of that data, but I can know that it exists. And being able to peer inside has value beyond just description. This is a secure data access portal, again, backed by Aristotle, where the metadata resides, and it says, hey, I know about some data. Let me tell you about it. Let me tell you about it. Here we record the number of children, the rent paid, the number of children under care, education, income, all of these things. If this data set was leaked, I'd be fired, killed, treason. Not a joke, actual treason. And I said, well, let's expose that. And this was the beginning of a process. This was an early prototype of a process that we're currently building that says, I can show you the data. I can show you that I can give you an understanding of the data. I can tell you what's in there. And I'll even let you select what you want from a variable bank. And I'll see if I can return data to you. If it's confidential, you're not getting anything. But I can at least tell you what's in there. I can tell you what the codes are so that you can even perform filtering on it. So you can say, I'm only interested in this population of interest, and from that, is that too confidential? Can I see that? Yes. Okay, I'll aggregate it up. I'll remove my filter. It essentially works like this. On the left, we have a metadata catalog. Somebody basically calls the front end, and it uses the information to run off to a secure area to perform analysis within a secure environment. The metadata essentially acts as a firewall, keeping everything within that box secure. At no stage will an end user ever see the data, handle the data manually, or even know where the data resides. The metadata provides that level of security and barrier to information. But now they have something that they can use. And that's the architecture diagram of that one. So essentially what we can see here is now we've put a secure layer between the end user and the data that allows them to understand the data and then put it on a map. Because we love maps. Maps are pretty cool. I like maps. They're very good at showing people what you're actually interested in. Everybody loves maps. So now here we can see a very early stage prototype where we're looking at using confidentialized techniques based on the metadata, querying techniques based on the metadata, and visualization techniques based on the metadata to provide an immediate understanding of that information. Now somebody can see this and know exactly what they're doing. It's kind of cool. I think so. So where do we go from here? This is, as I said, a prototype, but we're pushing forward. If you've got a keen eye, you will have noticed there were some flaws. We don't currently have the code sets in there. We didn't ask them to put them in. So what we're slowly doing is trying to look at A, how to import those code sets into the system in an easy way, but also using that to inform the user interface. Instead of seeing APRA and CISPR, APRA and CISPR, I want to see what that actually means. I want to know what that means. This one, can anybody tell me why that's funny and wrong? It's actually pretty funny. You guys are data guys, you'll get it. Come on, it's hilarious. Okay, spoil the fun. This is a license number. What they've done is they've identified that it's a number, and they've shown you quartiles of that number. So you can see like how many people have an ID number between 2100 and 3800. Doesn't really tell you very much. Quantiles of identifiers don't work. It doesn't help me to understand that this dot has an identifier between here and here. What we're looking at doing is using the value domain and saying it's not a number. It looks like a number. It only contains characters 0 to 9, but it's not a number. There's a very semantic difference between a number and a piece of text that has digits in it. And we want to say, how can we use that to inform the user interface? And lastly, we want to start looking at using the code? No. Using the codes. Geography. That's right, geography. Last step, geography. So at the moment, we're primarily based on latitudes and longitudes, and previous systems exist to use semi-hard-coded information about states. What I think is really cool is eventually we're going to get to the point where if I'm looking at an address or a location and I can say the object of interest, the unit of interest regarding this piece of data is an address, that's mappable. So that I can map a state or a territory or a province or a line or a polygon or a lake. I want to be able to map all of that information out without having to implicitly add the lat longs. So we're working on that. Lessons learned. 1, education is key. And I can understand, coming to a place like this, we have an intrinsic understanding of what metadata is. We all speak the same language. We all understand the same things. But there are so many people out there who are constantly entering the field. If you saw our poster at the poster session on Wednesday, we looked at the number of new graduates who are coming into postgraduate and graduate degrees. And you go, that's a lot of people who are coming out with very limited knowledge, who are kind of thrown into the deep end and said, provide all of the metadata with the data that you're producing today. They've got grants, they've got funding, there's so much stuff to do. Education at a basic level is key. Compromise. I felt terrible about asking people to provide metadata in CSVs. I felt scared coming to IASSIST and saying, I think CSVs are a great way to record metadata. It's not the best way to do it. But compromise exists for us to start today. Metadata has value when it's grown upon. When you start with an agency who has nothing, you need to get them on the train. You need to kind of help them along the way, baby steps. CSVs, we can do this. And deliver. A big part of this was us being able to show those maps and say, here's a map. You can see it from your data. It's important for you to add more in. And they looked at that and they said, cool, that's a gift they can take back to the rest of their agency and say, this is what we're doing. So ultimately, yeah, education, compromise, and delivery of products that kind of help people see what they're doing. Thank you very much. Thank you for your time, and thank you for staying for the Friday session. I understand that was really hard. So I'll open the floor to some questions. Yes?
I was wondering, you mentioned the visualization that you showed, and you mentioned that it was based on the metadata, and I was wondering if it was based on the metadata or the data themselves.
Both. So we had CSVs of information. We had an actual data set, and then we paired that with the metadata as well to kind of give it that extra flair. So the data set would have a record of the column header. We will be able to use that to pair back to the metadata to provide an improved visualization, to provide improved information in the screens. Okay?
Yeah, so you're using an ISO standard to handle the metadata for the data that you're handling. Are you also using the standard to handle the geographic metadata?
Not yet, and that was one thing where There was a standard that was produced by the CSIRO for this for national map called CSV Geo AU. That was a description language to say which, like when you saw a column, this is the geographies it matched back to. And it works, and it's really good. It's that compromise. But it's very, very hard-coded in what it accepts. There is discussions towards us looking at being able to record the geographic metadata required for polygons, for states and such. But that's like a longer-term strategy.
Look at ISO 19115.
Yeah. So, thank you. Any other questions? If you're interested, those are a bunch of links. We have a live demo. Aristotle Metadata.gov.au is our demonstration site. It has a couple of data sets on there. We're going to keep refreshing those. If you want something to demo, that's a good place to go and to show that value of metadata. And then, yeah, if you're interested in resources, look us up. Thank you very much.
Thank you.